everybody. Now, when I get up here, it's usually because I have something important to say.
Okay.
Don't hurt yourself.
Thank you. You got my back, right? In case of all, you're my spotter.
I don't know.
So, let me. I want you to put my life above yours. Okay? All right? If I should fall. So, what I'm saying is that there's a very good chance, like 100%, that this information we're going to discuss next is going to be on the test. But it's critical to understanding the nervous system. Okay? It's 4 basic definitions. A nucleus is the cluster of nerve cell bodies within the central nervous system. A nucleus is a cluster of nerve cell bodies within the central nervous system. Oftentimes I'll differentiate that from a ganglion, G-A-N-G-L-I-O-N. A ganglion is a cluster of nerve cell bodies within the peripheral nervous system. See what the difference is? Central versus peripheral. Okay. A tract, T-R-A-C-T.
T-R-S-E-T?
T-R-A-C-T, a tract, is a bundle of axons within the central nervous system. Whereas a nerve is a bundle of axons within the peripheral nervous system. Now, what's important to note is that a nerve is not a neuron. A neuron is simply the functional cell within the nervous system, consisting of a nerve cell body, an axon, and one or more dendrites. So don't confuse nerve with neuron. Now, is a nerve a bundle of neurons within the central nervous system? No. A nerve does not contain cell bodies. It's a bundle of axons. And it's within the peripheral nervous system. So make sure that you have your definitions down. In order for us to communicate, you have to understand the subtle differences between these 4 structures, or 5 structures. In fact, this is so important that when you get to this, when you're studying, I want you to stop and pay a lot of heed to it. So I'm going to ask you to take a highlighter and to highlight what you just wrote down. Yeah, yellow highlighter.
Why yellow? That's racist.
Okay. Now, once you do that, I want you to take a dark marker, and personally, I like a dark purple, a black, or blue. And what I want you to do is put plenty of stars
Watch this be the one thing I don't know on the test.
all the way around what you just wrote. To indicate this is some pretty important stuff. Okay? I don't mind if they're 5 pointed stars or 6 pointed. Doesn't make any difference to me. Then I'm going to add some finishing touches just to make sure you don't bypass this. I'm going to have you take a red marker and do kind of like a stop sign that says stop. Put it right there next to your definitions. Okay.
You writing on my paper?
Just help you
Writing
here.
on my paper.
So finish it up. And then finally,
Colin.
for some aesthetic value, you might want to
Just
put in a
look at
couple
your
of
phone.
these.
When it gets there.
Those are just birds.
What are birds?
Next to the stop sign.
Oh.
Those are like 3rd grade birds.
He doesn't care.
Wow.
I don't know. All of high school, those
This
are what
is some
my-
good work here. Look
That's
at
why I
this
took a
here.
picture of it. That's what I
nice.
sent you.
That's nice.
She had to go into like clip art just to get those stars.
That's dedication.
Nice.
Colin, it's just the one thing that's not gonna be on the.
I'm not gonna get that on the Death Watch. I know everything
I
else.
didn't get it.
I'm gonna know like the hardest concept,
Great.
and then I'm just gonna.
Folks, is this good?
No, it
Yeah, it
doesn't
is.
say in
Let me help you.
Okay.
Jake, when you study this, I want there to be no doubt
Jake, your notebooks for one.
that this is important stuff.
I hope Jake.
Good luck reading everything on the other side of the page.
Great.
And can you throw a little highlighter on that?
Is it okay if I highlight your page?
No, this is for his benefit. Up here is what you want to highlight.
I'm making a circle and then I'm.
Okay.
I don't know.
A little bit better. A little bit better.
Sometimes color distracts people.
Yeah.
I did it lightly
You're
because it's his notebook. Would you like it thicker? It's all about consent here.
So it says here, let's look back at our spinal cord. It says in the spinal cord, the central canal is surrounded by gray matter. So most of this gray matter is made up of nerve cell bodies, okay, clustered into nuclei. And then the white matter around it is made up of myelinated tracts. Bundles of axons that are running up and down the spinal cord like a superhighway. In fact, those tracks that are descending down the spinal cord are going to be motor tracks, carrying impulses from upstairs. Whereas those tracks that are headed up the spinal cord toward the brain, those are going to be sensory tracks, carrying afferent information, maybe about proprioception or touch, pain.
So there's both in the white matter?
Yeah, the white matter that, particularly within the spinal cord, it contains tracks that are coming down from the brain as well as moving up toward the brain. The ones that are descending are motor, ascending sensory. It's an information superhighway, if you will.
And how would you know which one is ascending or descending in the spinal?
Yeah.
Like if you
It's
you
just-
if you
It's just because of the anatomic studies that we know.
Okay.
so if you showed us a picture, we wouldn't be
In
able
fact,
to tell
I'll
the
say
difference.
this, is that tracks are different from nerves. A nerve, a bundle of axons within the peripheral nervous system, is surrounded by a connective tissue sheath. So it's easy to separate one nerve from another. Tracks don't have connective tissue sheaths. So it's hard to make out one tract and distinguish it from another.
Okay. So it's not like we're gonna have like that on a practical or something.
Well, you'll have to know where certain tracks run, but we'll
Right.
specify.
Okay.
Okay? This is a frontal section through the brain. Okay? And I want to use it just to demonstrate certain structures. This frontal section is cutting the lateral ventricle here, kind of in cross section. So these are the two lateral ventricles here. And this gray matter here, these are thalamic nuclei. Okay, in other words, these are clusters of nerve cell bodies within the thalamus on either side. And there's a little strand of white matter in here as well, myelinated axons. But you notice there's a space here between the right and left thalamus, and that's the third ventricle. Now, we haven't cut the brain in the right plane to demonstrate that opening between the lateral ventricle and the third ventricle, but we can see all three ventricles, the two lateral and the third in this particular plane. Okay. Now, lateral to the thalamus on either side, you see this band of white matter. This is called the internal capsule. The internal capsule is going to carry descending motor tracts that originate here within the cortex. So these motor tracts are going to carry impulses for skeletal muscle movement. Okay? The internal capsule is going to serve to connect the cortex above with the brainstem below. These internal capsules also carry ascending tracts, carrying sensory information up toward the cortex. Now, in this view, there's another important band of white matter that we've already alluded to. It's this band right here that's connecting the right hemisphere to the left hemisphere.
Corpus.
This is the corpus callosum. Now, deep within the hemispheres, there are three very important nuclei. These two situated lateral to the lateral ventricles, and these two groups situated lateral to the internal capsule. These three groups of nuclei are part of the basal nuclei. These basal nuclei are located deep within the hemisphere and help to modulate muscle movement. We'll talk about these more later, but for instance, the name of this one is not, it doesn't have here, putamen. The name of this one here is globus pallidus, and this one, it is labeled, but it's the caudate nucleus. You don't have to write it down now because we'll pick it up later. Okay. Now, notice I threw out some terms. Not that I expect you to pick it all up at one time, but a lot of learning the central nervous system is all about repetition. So I'm going to say these words or these names again and again and again, so you start to feel comfortable with them. Now what I'd like to do is start by talking about the hemispheres. Remember we said there are four components, the largest of which is the cerebral hemispheres. The hemispheres make up 83% of the mass of the brain. Okay? And it turns out that there are four lobes within each hemisphere. Frontal, parietal, temporal, and occipital.
It's funny how those are named.
Yeah, isn't that correct?
Sounds really familiar.
Never
Frontal,
heard that before.
parietal, temporal, and occipital.
Now we know why you did that on your test. Now,
Now, if you look at the surface
I
of
know
the
what you said,
brain,
but I don't know what you're talking about.
because you got
it has
a s-
convexities or ridges. That's what that is. And we call each of these a gyrus. If I'm going to use plural, I'd say gyri. It's like an alumnus and alumni. Now, between these peaks or these ridges, you have little grooves here. Each groove is called a sulcus. And if we wanted to go plural on you, I'd say sulci. If I wanted to differentiate a particularly deep sulcus or groove, instead of calling it a sulcus, I'd call it a fissure. A fissure. In fact, if you look here at the surface of the brain, there's a very deep groove that's running along the mid-sagittal plane right here. Okay? This is called the longitudinal fissure because it's deeper than the typical sulcus. And in fact, in frontal section, look what I'm doing. I'm drawing here your longitudinal fissure. Why I like that. It's very deep compared to the other sulci. Okay, it's going to separate the brain into a right and left hemisphere. Okay, let's do this. Anatomy is very, very visual.
What kind of learner are you? Kinetic, aesthetic?
Oh, I'm all
You're
about
visual?
the visual, yeah, yeah. Okay, so we're gonna make our big old oval as if we're looking down onto the surface of the brain from above. So let's draw then our longitudinal, draw in the middle here. Let's draw our longitudinal fissure. The longitudinal fissure is a very, very important topographical feature. It's a landmark. And there's a second important landmark that runs perpendicular to it. It's called the central sulcus.
Is that one harder to see on a real brain?
Well, it's not quite as deep, so for that reason, it might be a little bit more difficult to see.
Because I thought I read something like that.
So here's your longitudinal fissure, and running perpendicular to it is your central sulcus. The central sulcus is going to serve to separate the frontal lobe on each side from what's behind it, what lobe? Parietal. Parietal. Now, there are less prominent sulci that serve to separate the parietal from the occipital lobes. But we won't have to know that name there, the name of that sulcus on either side. Okay. So looking down from above, the longitudinal fissure separates the left hemisphere from the right, and the central sulcus separates the frontal lobes from the parietal. And then we go back here as the occipital. But look here. There's a fourth lobe that we can't visualize from this view. We have to go lateral to see that. We have to look at this type of image. In this type of image, we pick up the fourth lobe, which is the temporal lobe. If we kind of picture our hand like a mitten sitting on top of the surface of the brain, the area deep to the thumb would be the temporal lobe. And there's a